Hi everyone, I will be teaching you how to use the Microsoft Excel in order to do descriptive statistics. And we will be working around these data values that we see here. So I'm going to zoom it in. All right, so the first thing you need to do is to make sure that you have the right tools in order to do descriptive statistics. And so if you're using MacBook, you can follow this easily. You go here to the Customize toolbar, and then we go to Tools, and then we go to Excel Add-ins, and then we tick this box here that says Analysis Toolpak. So remember that there has to be a check beside it, and then you click OK. Now, the Analysis Toolpak will give you the Data Analysis tool on Excel, and we will be able to find it here in this tab, Data, and to the rightmost of it would be the Data Analysis tool. And when we click it, we see here the different analysis tools that we can work with. But of course, what we are looking for would be descriptive statistics. Now, we have input range here. This contains all of the cells with the data values you want to work with. And you can group it by columns or rows. So it means that you can process multiple data sets all at once. And what we have here would be the data sets Monday, Tuesday, and Wednesday. And we can choose to highlight all of these here. And then we grouped it by columns because these are all in columns. Now the next part is the output range. It means the cell where you would want the output to come out. So let's say we just want to put it here beside our data sets. And then we click Summary Statistics. It's up to you if you want to add here a confidence level, etc. So we press here, OK. And this is what comes out. So we have 3 columns corresponding to the 3 data values. Let's say this one is Monday, and then we have here Tuesday, and then the last one is Wednesday. So I'm going to highlight here the different things that we need to give focus on. So we have the mean, the median, mode, standard deviation, kurtosis range, kurtosis skewness range. So this will be the major elements here, although some of the elements would still be pretty much important. So here the mean or the average is 57.625. So mean, median, and mode would refer to the measures of center. And then we have here the median, which is the middlemost number, is 54.5. So it means that when you arrange all of the values here in Monday according to ascending order, let's sort it out from smallest to largest. Okay, so we have here the different values, and it says in the results that the median or the middlemost number would be found in between 47 and 62, which is 54.5. And we notice here that we have 3 values that are all 36, and it has been recurring the most here in data set. So it is our mode. Understanding the measures of center is important because they are the reference point. So you would know how far exactly different points are in the data set because of how far they are from the middlemost number or the average or even the mode. Now we go to the measures of variability. We have here the standard deviation and we have sample variance. So we can go to standard deviation. Standard deviation will tell you about how far the data values are from each other. So we have here 21.88892414, basically 21.89. So how far data values are as adjusted here would depend to the data values that we have. So it's important that you also know what your data values are, and you can look at the minimum and maximum numbers. And we are dealing with numbers that are from 36 to 87. So given that you're only working with the numbers 36 to 87, 21.89 is a big number if you are looking at how variable data are or how far they are from each other. So it means that the data is spread out, and this is supported by our kurtosis that is negative 1.89. When you get a negative kurtosis, it means that they are heavy-tailed, and so they are spread out. And now we have a skewness, which is 0.315. If you get a skewness that is a positive, it means that it is skewed to the right. So imagine that there is a quadrant. All of the negative values lie on the left side of 0, and then all of the positive values would lie on the right side of 0. So all in all, this output is telling us that the data is spread out because of its standard deviation and its kurtosis, and it is skewed to the right. Okay, so there are other ways also on how to measure the center. We already know mean, median, mode. We also have the mid-range, geometric mean, and the trimmed mean. So if you don't have the data analysis tool here, you may opt to solve for the measures of center manually using the Excel formulas. So for the mean, you can simply type in average because it is the same. So we have here equal average, open parenthesis, and then you highlight all of these cells, close parenthesis, and it gives you 57.625. And it is equal to the result that we have here. As for median, you can type in equal to median and then highlight all the data values again, close parenthesis, and then we get a 54.5, which is the same as what we got from the data analysis. As for mode, this would be more manual because you really need to look at the numbers that are repeating. So you can use frequency, a frequency, etc. But the point here is that you really need to know the numbers of the data values. And so if you are dealing with a lot of numbers, this may not be the best way. It's recommended that you use Data Analysis Toolpak. For the mid-range, how you do this is that you add the minimum and the maximum numbers, and then you divide them by 2. So it is important that your numbers are already sorted out from lowest to highest so that it would be easier for you to look for the minimum and maximum numbers. So again, this one would be more manual, and we add the minimum and maximum numbers, which are 36 plus 87 divided by 2, and we now have 61.5. The last 3 measures of center cannot be found here on the descriptive statistics. Okay, we have geometric mean. For geometric mean, we have the function equal to geo mean, and then open parenthesis, and then you highlight all of these again, and it will give you the number 54.008046. And then for trimmed mean, equal to trim mean, open parenthesis, and then you highlight the numbers again, comma, and how many percent would you like to trim off from the whole data set. So let's say we want to put here 10%, and it will give you a 57.625 answer. Now, the questions surrounding these measures of center would be, number 1, do the measures of center agree? So let's say here with the mode 36, we see that there are differences in the numbers. Like for mean, we have 57.63, median is 54.5, mode is 36, mid-range is 61.5, geometric mean is 54, and trimmed mean is 57.625. And the only 2 values here that agree with each other would be mean and trimmed mean, which is 57.65. The other values are not the same at all. The difference between these values are kind of big as well, so they do not agree with each other. Now, if you ask about how appropriate or how reasonable these measures are, it would depend on the context. If we are looking at these numbers as scores from an exam, then geometric mean or mode may not be the reasonable measures for this one. Mean would tell you the average scores of all the people with these data values. Median would basically just give you the middlemost number, which is not also reasonable in that case. Mid-range is just an estimator, so it's not always very accurate. As you can see here, 57.625 versus a 61.5. That's a pretty big difference between the two. Geometric mean is also not applicable because geometric mean is often used for growth rates, because in growth rates, you look at both the expenses, let's say, and then the sales. So there are two variables working together because the changes in those variables kind of move together. And then trimmed mean is trying to trim out any outliers in there. So if you find that there are unusual data that are too high or too low, then the trimmed mean would trim it off. But of course here it might not have detected all of those outliers, and so it gave us basically just the mean, which is why it's equal now to our mean of 57.625. So yeah, the analysis would really depend on the context, and it's very important that you understand what it is exactly that you are solving. Now let us go to the measures of variability, and first we have range, sample variance, standard deviation. Oops. Of course, there would be different ways on how to solve for the measures of variability, even with the measures of center, because there are formulas that you can follow. But since we are using MS Excel, the formulas or the functions would be a lot more easier. Now for range, since this is fairly easy, you don't need to use MS Excel anymore. You just need to subtract 36 from 87. So we have 87 minus 36, and that is our range, 51, which is equal to what we have earlier from descriptive statistics. And as for sample variance, we have the functions var.p and var.s. var.p refers to a population, while var.s would refer to a sample size. So let us say we're using sample, and then we highlight again all of the numbers we have here, and it gives us 479.125, which is equal to what we have here from the descriptive analysis result. But let's just say we are using var.p and see how different the answer would be. And it gives us 419.23438. So there's quite a big difference of about 60. Now we have standard deviation. The function for standard deviation is Stdv. We also have the .p and .s options, but we're going to use just the sample size. And then highlight everything. And we get 21.89 as the answer, which is equal to what we got so far earlier. But just out of curiosity, let us compute also for standard deviation dot population. Highlight everything again, and it gives us 20.47. The difference may not be that big, but a difference is still a difference. So this is how you use MS Excel in order to do descriptive statistics, as well as how to interpret the results. If you have any questions, you may comment below and I will try to answer as clear and as concise as possible. So thank you so much for watching. Make sure to like, subscribe, and hit the bell button. Thanks everyone.